welcome back, Prep Station Physics UTME 2025. Okay, let's quickly look at the last question and then we move to another topic. An Air Force jet flying with a speed of this went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? Flying with a speed. So you have the speed. Let's say this is initial velocity of 335 meters per second. Went past an anti-aircraft. How far is the aircraft 5 seconds later when the gun was fired? So you have T is equal to 5 seconds. What are we looking for now? We are looking for distance, question mark. There's something else we need. Okay, we have velocity, we have time, and then what else? We are looking for distance. How far is the aircraft? How far is the aircraft? Okay, so this should be V, initial velocity. So this should be V, final velocity, and then we have U equals to initial velocity 0. So if I have this in place, then I can apply the second equation of motion, which says distance equals to V plus U over 2, bracket open and close, and then T. So if I apply this formula, I should be able to get the answer where you have 335 plus 0 over 2, bracket open and close, times 5. So if I do this, I should be able to get the answer to this question. So let's quickly take another topic. Lesson 4, wave motion. All right, wave motion. And then we are going to consider these few subtopics under that. First, we look at wave motion. We look at vibrating systems as source of waves. We look at relationship between frequency and wavelength. And then let's start. First, what is wave? Now, wave can be described as what? A disturbance which travels through a medium just for the purpose of what? Transferring energy. For example, if you have a piece of wood in a pool of water and then drop a stone in the same pool of water, you will notice something on the surface of the water. Ripples will be formed. Now, as those ripples are being formed, the wood on the water will start moving. Now, according to Newton's law, the wood is not supposed to move not until force has been applied. So it means the wave that has been generated by dropping the stone has created what? Energy, which, of course, enable the wood to move. So wave is a disturbance. It travels through a medium, transfer energy, and then leave the medium without displacing anything. Now, common terms used in wave. Number one, we have amplitude. Now, what is amplitude? Permit me to just sketch this diagram. So amplitude is the highest peak of wave, highest peak. This is a wave motion, a transverse wave motion. So this point here is called the amplitude. It can also be this. This is called the amplitude. It is the highest point of the wave. You can also define it as the maximum displacement of a particle from rest point. Now, what is wavelength? What is wavelength? I should have a diagram to explain this. Yep. So wavelength is the distance from trough to trough, or from crest to crest. The highest point of a wave motion is called crest, while the lowest point is called trough. Okay? So the height is what is called amplitude. I explained that before. And then the distance from trough to trough, or the distance from crest to crest, it can also be this. The distance from crest to crest is also known as wavelength. Okay, so let's move forward. Okay, I've explained what is amplitude. I've explained what is wavelength, the distance between two consecutive points on the wave, and then amplitude is half the height of the wave. What does that mean? Half the height of the wave. From this point, this is the height of the wave. So half the height is called amplitude. That is this. Is called amplitude. Half the height of the wave is called amplitude. So let's move forward. Common terms used. What is frequency? Frequency is the number of waves passing a point each second. The number of waves. You can also say is the number of revolution. Let me write that down. We use these terms interchangeably. You can say it's revolution. You can call it cycles. You can call it oscillations. So frequency is the number of revolutions, the number of cycles, the number of oscillation made in how many seconds? Just one. So number of oscillation per second. So that is the formula for frequency. So N represents the number of revolution or number of cycles or number of oscillation made in what? 1 second. The unit for frequency is called hertz, named after the scientist, hertz. And then the short form is Hz. That is the unit for frequency. Okay? If the wave below passes a point in 1 second, what is the frequency? So this is wave motion, and we want to find out what is the frequency. Based on definition, frequency is number of waves. So how do you count the number of waves in this diagram? Now from this point to this point is half of the wave. From this point to this point is another half. So that is 1. From this point to this point is half. From this point to this point is another half. So I have 2 waves, and then you continue like that. 3 waves, you continue. So here we have 4 waves. So I can simply say the frequency of this wave is what? 4 hertz. 4 hertz. The meaning of this 4 hertz is that we have 4 waves passing this point in just 1 second. All right, let's quickly do this. Let's test our understanding. You have number of waves, number of cycles, the time, and the frequency. Now, remember the formula. Remember the formula. Frequency is equal to number of oscillation per time. So, what are the number of oscillation here? You can count. From this point to this point is 1, this 2, this 3, this 4, this 5, this 6. So you have this as 6. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. And then what do you have here? This is just 1. The timer remains the same. So what will be the frequency? Divide cycle by time, just like what you have here. So 6 divided by 2, that should give me 3. 10 divided by 2, that should give me 5. And then 1 divided by 2, that will give me 0.5 hertz. So that is how to calculate frequency. Let me show you from the table. I've done that already. So you have 6, 10, 1. So the frequency will be 3. This will be 5. And then this will be 0.5. I want to believe that is simple and clear enough. Still on common terms, use period. Now, what is period? Period is the time taken to complete one oscillation. Now, don't confuse that with frequency. Frequency is the number of oscillations made in 1 second. But period is the time taken to go round 1 cycle. So they are not the same thing. Now look at this. Period is T over N, while frequency is N over T. Then we have the wave speed. The wave speed. Now the wave equation. Let's look at the wave equation. All right. Now the definition for frequency is N over T. The definition for period is T over N. So it's like saying one is a flip of the other. So if that is the case, then I can say T is equal to 1 over F. So this is the first equation of motion. And then the other one is speed is equal to lambda over period. Let me quickly explain why we have it this way. Normally, speed is defined as distance over time. Distance over time. But because we are dealing with wave, the distance for wave is called wavelength, lambda. So instead of using d, I'll be using lambda. And then the time taken to make one wavelength is called period. So this is t. So the formula for wave speed is lambda over period. But then, because t is equal to 1 over f, then I can flip this. And so this formula will now become v equals to f lambda, because t is the same thing as 1 over f. So that is how we arrive at these two formulas. Okay? Let's move. Classify waves in terms of material for propagation. We have two methods of classifying waves. Number one is the material, and then number two is the mode of propagation. Now, if you are classifying wave in terms of material, then we should be looking at what? Mechanical waves and electromagnetic waves. So in terms of material, we have mechanical waves. What is mechanical wave, or what are mechanical waves? It's a wave that is not capable of transmitting its energy through a vacuum. What does that mean? It means mechanical waves are waves that requires what? Material medium for their propagation. Material medium. For example, sound wave. You cannot transmit sound without considering air, okay? You have the wind and all of that. So let's move forward. Then we have the electromagnetic wave. These are waves that is capable of transmitting its energy through a vacuum. In other words, we are saying that these forms of waves does not require material medium. For example, the radio signal. You don't need material medium to transmit radio signal. And we have about 7 of them in that list, which is called the electromagnetic spectrum. That is the GX, U, V, I, M, R. G for gamma, X for X-ray, U for ultraviolet, V for visible light, I for infrared, M for microwave, and R for radio wave. Now, radio wave is the wave used in transmission of telecommunication. For example, radio signals and TV signals. Okay, so I don't need any medium to transmit a signal from a radio station or television station to where I am. So these forms of wave, they are called electromagnetic waves. All right, a transverse wave is a wave in which the particle of the medium are displaced. Okay, so this is another form of classification based on mode of propagation. So in terms of mode of propagation, we have transverse waves and longitudinal waves. Now, how do you differentiate these two? It's very simple. If the direction of producing the wave is to my right, and then the direction of movement of the wave is also to my right, it means this wave is parallel to the source. You simply call this longitudinal wave. In other words, I'm saying if the direction of the movement of the wave is the same as the source producing it, call it longitudinal wave. But if the direction of the wave is perpendicular to the source producing it, in other words, it forms 90 degrees with the source, simply call this transverse wave. Transverse wave. Example, if you are playing a guitar, okay, you strum the guitar this way vertically, but the sound wave travels horizontally. So that is example of transverse wave. Let's move quickly. All right, this diagram illustrates how to produce transverse wave, okay? If you have a rope tied to a point and then just move the rope up and down, you will produce transverse wave. Now, if you have a spring, tie it, attach it to one end, pull it at the other end, then you should be able to produce this. All right, let's have a short break. We'll be right back.